Okay, so here I write number of balls, right? Okay, and then because
We were doing areas related to circles, right?
Yeah, ma'am, we are not learning frequent. We are not learning statistics.
just I'm really sorry. I actually opened class 9th. Just my mistake. I'm really sorry. It- oh yes, we were doing this. Okay, so in your batch, okay. Oh yeah, actually I have continuous classes, so it just slipped my mind. I thought I'm teaching class 9th. Okay, 10th question we have done. So 11th we have to do. Okay, just a minute. Let me open the book. Okay, exercise 12.3 we are doing, right? Mm, I think one question I gave in the homework, the 10th question, right?
Yes, ma'am.
Have you
Yes.
completed?
Yes.
Martin, have you completed?
Yes.
Almost, ma'am.
Oh, okay, then it's easy. You can do it. Let us do 11th. Okay, so on a square handkerchief, 9 circular designs, each of radius 7 centimeter are made. Okay. Find the area of the remaining portion of the handkerchief. I think this is very easy, isn't it?
Also, we just take all the circles and subtract
Hmm,
by the area of the square.
exactly. Now, area of circle you can easily find out because radius is given. Okay. Now, what about the side of the square? How will you find the area?
So radius 7 centimeter, right? So then diameter is equal to the side.
No, diameter is just, isn't it, Martin?
Oh yeah.
I mean,
Oh,
only this is
that is a
diameter.
small circle.
So what will you do?
Times 3.
See, here, how will you write it? Like radius of circle.
We multiply it by 3. That was 3 times.
First of all, which is given, this is radius. All right. So radius of circle is 7 centimeter. That's fine. So we can find area. Area is pi r square. I mean, area of one circle, you can say, right? Okay. So one circle is pi r square. And how many circles are there? So 1, 2, 3, 9 circles are there. So directly you can find 9. Area of 9 circle will be 9 into pi r square. Is that clear? Okay. So 9 into 22 by 7 into r. Now, because all the circle are having the same radius, so obviously their area will be same. So I have just multiplied by 9. Is that clear? Same area they all are having.
Yes, ma'am.
R is 7. So 7 into 7 and then centimeter square. So 1 7 cancels out, right? So you have 22 into 7 into 9 is 63 centimeter square. Now can you multiply quickly? Okay, so I'm getting 1386 centimeter square. Is that clear?
Oh yeah. Also.
Okay. Now I need the side of the square. right? So I need the diameter of one circle, and then I'll multiply that by 3 because every circle is touching each other, right? So if I take 3 times the diameter, I'll get the side. So radius is given. So let us find out the diameter of one circle. So diameter of one circle will be 2 into 7 centimeter, right? So that will be 14 centimeter. Is that clear?
Yeah, ma'am.
Okay. So we can say side of square will be 3 into diameter. So this will be 42 centimeter. Clear? Now you have got the side, you can find area of the square. So area of square is side square. So that means 42 centimeter multiplied by 42 centimeter. Okay, Arshia, how much is this equal to?
One 1764.
Okay, 1764 centimeter square. Now we have to subtract, that's it, right? So area of shaded region. Okay, not shaded, it's called remaining region in the question, right? Okay, area of remaining region will be area of square and minus area of 9 circles. Clear? Okay, so area of square we have found out 1764 centimeter square minus area of 9 circles. So directly we have found 1386 centimeter square. Okay, Mana, what will you get now? Just subtract
Oh, ma'am, it's 378.
378. This was easy, right?
Yeah.
Okay, then next question now. Have you written?
Yeah, ma'am.
Yes, ma'am.
Okay. Hello, who is this Shahina Abdul?
Ma'am, this is Arshi. I joined from my phone.
Okay, fine. Okay, now in this question, see here, all of you. In this figure, OACB, can you see that? OACB, right, is a quadrant of a circle with center O and radius 3.5 centimeter. So that means this side is 3.5 centimeter, clear? And also this side. Is that okay?
Yes, ma'am.
Okay. Now, if OD is 2 centimeters. So from here to here, it is given 2 centimeter. Find the area of quadrant OACB. Quadrant is simple, it's a sector, right? I mean, you divide the circle into 4 equal parts. So this one quadrant is basically a sector of the circle. And what is the angle here? Yes, what is the center angle in case of a quadrant? 90 degree, you know?
Yes, ma'am.
I mean, you are dividing the complete angle 360 into 4 equal parts, right? So you get 90 degree. Is that okay?
Yeah, ma'am.
Okay, or you can write also if you like complete angle will be 360. And because it's a quadrant, that means 1/4 part of a circle. So that you get 90 degree, right? Now, area of quadrant. OACB is basically area of sector. So that is theta by 360 into pi r square. Clear? Now put values. So you have 90 divided by 360 into, okay, 22 by 7 into radius is 3.5. So 3.5 centimeter multiplied by 3.5 centimeter. Clear? Okay, now you can solve it. So 1 0 cancels out and 9 into 4, right? So you get 1 by 4 into 22 by 7. And I remove the decimal, so I get 35 by 10 into 35 by 10 centimeter square. Clear? Okay, so now this is 7 into 1 and 7 into 5. And I can also reduce, so 5 into 1, 5 into 2, right? Oh, okay, then 2 into 1 and then 2 into 11. Mm. Or if you don't want to disturb the 10, you could have divided by this 4 also. But anyway, okay, no problem. So now what I left with, so in the numerator, I have 11 multiplied by 35, right? And denominator, I have 4 multiplied by 10, that's it, right? So quickly multiply 35 into 11. So I'm getting 385. Is that right? Okay, divided by 4 into 10, right? So first I divide this by 4. So what I get, you can separately do it if you are not able to do directly, so do it separately. So 4 into 8 is 32, right? No, sorry, 4 into 9, it will go 36. So 25, then you have 4 into 6 is 24, then you have 1. So there's a point, then 4 into 2 is 8, then you have 20, so 4 into 5. So you get 96.25 divided by 10, right? Centimeter square.
How did 10 get cancelled there?
Okay. I cancelled it by 5, Martin. There was a 5 in the numerator, right? 7 into 5 is 35, and then from that 5 I get 5 into 2 is 10, and then 2 I cancel 22, so I get 11.
Okay.
Okay, so 96.25 divided by 10. Now if you are confused, so do extra steps. First you remove the decimal, right? Sometimes the student make mistake while shifting decimal, so I always say make one extra step, there is no problem. So this will be 9625 and then you will get 100, right? And then you have one extra 10 already. Is that clear? If you remove the decimal of the numerator, so you have to divide by 2 zeros. Is that clear? So now total you
Yeah.
have 30 in the denominator. So now you can place 9, 6, 2, 5 and then 1, 2, 3. So after 3 places, you can put your decimal. So this is the area of one quadrant, 9.625 centimeters square. Okay, so area of quadrant we have found. Now we have to find the area of shaded region. How will I find it? Tell me. Yes, Martin. What will I do?
Yeah,
For shaded region, what will I do?
shade. We found the whole sector's area right now, right? So it's a quadrilateral.
Quadrilateral. No, I need the area of the shaded region. So what will I do? Mana, what will I do here?
Oh, I got it. We can take the area of the quadrant minus area of the triangle.
Exactly. So the triangle we can find out. And everything is already given. The radius was 3.5, right?
Yeah.
Centimeter. Okay. And I think OD is also given in the question, which is 2 centimeters. Is that clear?
Yes, ma'am.
Okay. So base is given and perpendicular is given.
Yeah.
Okay. So area of triangle.
One
Uh,
by two base into height.
yeah, BOD. So that is half into base, which is BO into height, which is OD, right? So half into 3.5 centimeter and OD is 2 centimeter, right? So 2 cancels out here and only 3.5 centimeter square you will get. Right. So area of shaded region will be area of quadrant, right? Which was O OC B, how I named it, OACB, right? OACB. Okay, minus area of triangle BOD. So we have already found everything. So 9.625 centimeters square and minus 3.5 centimeters square. You can separately do it. 625 and then 3.5. So you can put 20. So this is 5, 2 and 1. 9 minus 3 is 6.1. 6.125. 6.125 centimeters square, right? You can reduce it to 2 places of decimal also if you wish. So you write this is approximately equal to. Is that clear? See, obviously, now please note one thing. 6.125 is obviously not equal to 6.12. Is that okay? Or if I round it off
Yeah.
because it's 5, so it will become 3. So obviously the two numbers are different. So we don't put equal to, we put this sign. I mean approximately equal to. Is that okay? So which is approximately equal to
Yeah, okay.
6.13 centimeters square. Now in NCRT, I think it is given in fractions, right? So I think 49 by 8 is the answer in NCRT. So if you convert that in decimal, let us see. 49 divided by 8. So 8 into, what will I do? 8 into 6 is how much? 48, right? So I get 1, then I put a 0. So 8 into 1 is 8. Then I get 2. So 8 into 2 is 16, right? And then you get 4 here, right? That becomes 40. So 8 into 5. So exactly this thing you are getting, 6.125. You can leave it 6.125 also, or you can round off to 2 places of decimal. I think you can leave the answer as it is, 6.125. Because you have exactly got it, right? Now, why they are getting in decimal, sorry, in fraction in NCRT? Because here, when we were finding this area, this, right, area of quadrant when I was finding, let me show you. Okay, note this step, right? Or even here. So instead of converting it into decimal, I can just keep it in fraction. Is that okay? And then I'll get it in fraction. Clear? Both are correct. Okay, next question now. Okay, question number 14. Oh, sorry, 13 we have to do. Anyway, let us do 14 first, then we will do 13. So AB and CD are respectively arcs of two concentric circles of radius 21 centimeter and 7 centimeter. So remember what is an arc? So this length is called arc. Clear? So AB is one arc and CD is another arc. Now radius of bigger circle is 21, which is given. Smaller, which is 7, also given in the figure, and center O. Okay. Now if center angle is 30 degree, find the area of the shaded region. This is easy, isn't it? What will you do here?
Yeah,
Yes, Arshia, what will you do in this question?
the biggest sector minus smallest.
Circle?
Yeah, like biggest sector minus smallest.
Sector, yes, okay. Yeah, okay, so directly you can write area of shaded region is equal to area of sector. Now to name a sector, what we do is, see, now see here, if I name it like this, OAB, right? The bigger sector OAB, but somebody can think it of a triangle, right? This is how we name a triangle OAB. So we take some imaginary point. Let's say there's a point here which I call E, let's say, right? So I'll name it OAEB. Now it will be a sector. Is that okay? This is how we name a sector. And similarly, you can just assume any point here, which is F. So minus area of sector OCFD. Is that okay? So that is
Yes, ma'am.
theta by 360 into pi. Now the radius is 21 centimeter square minus theta by 360 into pi. Now here the radius is, or you can first write capital R square minus a small r square, right? And then you can put value. So theta by 360 into pi, I can take outside. So it will be r square minus r square. Okay. So theta is 30 divided by 360. Pi will be 22 by 7. And capital R is 21 whole square minus 7 whole square, and then centimeter square I can write outside. See, for examination purpose, I think this is a good question. This is like very direct application of formula, so it can become in a 2-marker kind of question. Okay, so now 0, 0 cancels out. So it is 1 upon 3 into 1 and 3 into 2, 12, and then 22 by 7. Then 21 into 21 is, I think, 141. You can check. 2 into 1 is 2. 2, 2. Oh no, it's 441. Sorry, 441 minus this is 49, and then centimeter square. Okay, now subtract it. So 1 upon 12 into 22 by 7. And what will you get? 11 minus 9 will be 2. Then you have 13 minus 4 will be, I think, 9. 392 centimeter square, right? Now, if you want to leave the answer in fraction, so you can just simplify this a little bit. 2 into 6 and 2 into 11, and then 2 into 3. Now 2 into 1, then 19. 2 into 9 is 18, then 12. So 2 into 6 is 12. Now can I divide this further? I think no. 7 into, 7 I can divide. 7 into 1, then 7 into 2 is 14, right? Then I get 56, and 7 into 8 is 56. So this becomes 11 into 28 and divided by 3 centimeters square. That you can multiply 28 into 11. So 308, I'm getting 308 divided by 3 centimeters square.
It's divided by 3. No?
Yes.
You wrote 2. Okay. No.
Yes, Harsha, are you here? Okay, she's not here. Mana is not here. Yes, Martin, done.
Yeah, ma'am, done.
Okay, 13th question I left in between. Okay, so a square OABC is inscribed in a quadrant And you have to find the shaded area. So this is easy, right? Quadrant minus a square. Now for quadrant, you already know the center angle theta, right, Martin?
Yeah, ma'am.
Which is 90 degree. Okay, now what about square? Now already side is given. OA is 20 centimeter in the question, right? Find the area of the shaded region and you have to use pi 3.14 this time. Now please do it here itself. Please solve it.
Ma'am, is OA the radius?
No, OA is not the radius, it's the side of the square, isn't it?
Okay.
Yeah, okay, so you don't know the radius here.
Yeah.
So what will you do? Okay, so radius is not given. Is inscribed in a quadrant, okay. Mm. Find the area of the shaded region. We can do one thing here to find radius. See, there isn't something extra we have to do. If I just draw a line here, I join it. I draw a diagonal, right? So
Okay.
basically, I have a triangle now, right? Now, because this is a square, Martin, so this side is 20. So obviously this side is also 20 because it's a square. And this angle is 90 degree because it's a square. So I can use Pythagoras theorem.
To find the hypotenuse.
Yeah, I'll get OB, right? So I'll get OB, and OB is what? OB is the radius of the circle. See, look at the circle now. OB is the radius of the circle, isn't it? It's touching the circumference.
Okay.
Yeah. And OB you can find by using Pythagoras theorem in this right angle triangle. Okay, let us solve it. So basically OB square will be equal to OA square plus AB square. Okay. So OB square will be OA is 20 whole square. AB is also, sorry, 20 whole square. So you will get centimeters. So OB square is 2 into 2, 4. 400 plus 400 centimeter square, right? So OB square will be 800 centimeter square. So OB will be square root of 800 and then centimeter square root will become actually centimeter, right? So you can simplify this a little bit, like this can be written like this: 8 into 100, right, Martin? Centimeter, I can write outside. Yes. Now, because 100 is a
It's
perfect square.
40, right? 40 is square.
Sorry, Martin.
Is OB equal to 40?
40? No.
OB.
OB 40, no. OB is under root of 800, I'm getting, right? Now I have to solve it. Under root of 800. So I have written 8 into 100 because 100 is a perfect square, right?
Yeah.
So I can take 10 outside the square root. Is that clear? So this 10 will come out and I'm left with under root of 8 centimeter. Now this 8 can also be written. You can factorize it. So 8 can be written as 2 into 2 into 2 centimeter, right? So one pair will come outside. So 10 into 2 and then 1, 2 will remain inside. So you get 20 root 2 centimeter, not 40.
But like 40 into 40 is 800, right?
This is plus, Martin. Where are you getting 40? Please tell me.
Square root of 800 is 40, right?
No, why 40, Martin? If you multiply 40 into 40, just do it. 0, right? Oh, sorry, you're multiplying. So 4 into 4 is 16 and then 2 0 will come. So it will be
Oh, okay.
1600. Yeah.
Okay.
So square root of 800, you have to do like this as I have done. Or you can directly do prime factorization if you know, if you want, but because it's a large number, so you can break it into smaller. So I've just separated 8 and 100 because I already know 100 is a perfect square of 10. So only a square root of 8 I'm having. Then I have prime factorized it. So after that, I mean, you can write now radius of quadrant is actually equal to OB, which you have found 20 under root 2 centimeter. Now you can find the area of the quadrant. Now please complete it. Yes, Martin, completed.
Yeah, I'm almost there.
Yeah. Okay, Martin, so that you can complete, right? Let's look at the next one.
Yeah, sure.
Okay, so in this figure, ABC is a quadrant of a circle of radius 14 centimeter, right? And a semicircle is drawn with BC. So basically this complete is a semicircle, this complete, okay? As you can see, as with BC as diameter, find the area of the shaded region. So just tell me what exactly you will find out here.
Area of the sector
Okay,
plus
so
area of the arc plus area of the arc.
arc. Uh, arc is length. There's no area for arc. Area is only for triangle, it's for sector, it's for segment. That's it. Arc is this is called arc, Martin. So we find its length, we don't find its area. Clear?
Yeah.
Come on, think about it.
In the semicircle, are the radius of both of them same?
Yeah, area, radius for segment will be same, radius for semicircle will be same. That's fine. But for segment, you need the central angle. That is also, I think, 90 degree, right?
Yeah.
So you want to approach it like this, but there's a problem, Martin. Now, this complete, which you are thinking, for example, I mention a point here. Let's say there's a point D, right? And here, let me mention a point E. So this A, B, D, C is not a sector, right?
Oh, what?
See, A, B, D, C. Can you see that? Like
Yeah,
this,
that's
this,
not a sector because it's
yeah,
joining
it's
semicircle
not a
A, B,
sector.
C.
And semicircle is only this much. Like only this much is a semicircle.
Oh,
Because here somewhere you will have the center. So this is a semicircle. See, what you can do here is, if you find this, for example, triangle, right? which is ABC, clear? And plus semicircle. Just try to understand. So you have got, that means the complete area of this figure you have got, clear?
Yeah.
I mean, this every area you will get triangle plus semicircle. Now, out of this, if you subtract sector, so you will be left with only the shaded portion. Sector this A, B, E, C. Understood?
Okay.
See,
Yeah.
sector is actually this. This is your sector, right? So this complete area you have already got. Now you subtract this sector area. So which area you will be left with? You will be left with only this much,
Okay.
right? So
Yeah.
this is what you will do here. So area of triangle now, half base into height. Now tell me what you know about it. So ABC is a quadrant of radius 14 centimeter. So that means this side is 14 centimeter, right?
Yeah.
This side is also 14 centimeter because it's a quadrant.
Oh, it's a triangle.
I mean, quadrant is this one, right? So this is also a radius, this is also a radius, this is also a radius. Everything is a radius. AB is also a radius, AC is
Yeah.
also a
Yeah.
radius. Okay. So now you know AB and you AC, so you can find the area of the triangle, half base into height. Clear?
Yeah.
Okay. Now you come to semicircle. So area of semicircle means you need radius, right? So do you know the radius here?
Is it also 14 centimeter?
No. Why? Why 14?
Do you use the Pythagoras theorem to find the?
Exactly. So first of all, you will find this side BC, right? By Pythagoras theorem. And then you will half it because BC is the diameter of the semicircle.
Ah.
That means half of BC will be the radius of semicircle. You can note steps. I'm not solving it. You can note it down. Right? So BC you will find from Pythagoras theorem. Right? Then half of BC is your radius of semicircle. So you will get the area of the semicircle also. Right? And for sector, what you need theta and you need radius. Both you know. Theta is 90 and radius is 14 centimeter. So can you complete it?
I'll try.
No, don't try. It's very easy, Martin. Just note this, this blue bubble I have drawn. So you have to find area of triangle ABC that you know half base into height. Clear? Then you need area of semicircle. Semicircle means half of circle. So you need only radius. And for radius, you need BC. So BC you will find from Pythagoras theorem. Simple. So BC square will be AB square plus AC square. So from here you will get BC, right? And that BC by 2 will be the radius of semicircle. Right? I think you can do it. Okay, let us quickly discuss the next one also. And you will try this also in the homework.
All right.
The last one. I'm giving you hints for it also. So it's look like this. Calculate the area of the design region. Right. In the figure, common between two quadrants of circle of radius 8 centimeter each. So, I mean, you can read over the figure like this. So basically you have a square, right? So from,
Yes.
if let's say this is the center of my circle, if I call it O, or I call it A, B, C, D, first of all. So A is one of the center of the circle. So it's a quadrant like this. Understand?
Uh,
Yeah. And I just join this diagonal. And if C is the center of another circle, then the quadrant will be this. Is that clear?
oh.
Yeah.
Oh, yeah. Okay.
Okay. So I actually need this area, this complete area. So one by one I'll do. I mean, I find just one quadrant. Let us take. Let us take only this one. A, B, and this is D, right? So let us find this area, and then we will multiply this area by 2 in the end. Is that clear? So this, I mean, this red area I'll get. Is that clear?
How?
Okay, so do you understand this figure? I've just drawn one quadrant. Clear?
Okay.
Yeah. So now, um, I mean, in this red area and this red area is same. Is that clear? I mean,
Oh, yeah.
I've just drawn a part of this figure here, right?
Okay, get it.
Yeah. Now I need this red area. So what will I do? Sector minus triangle, right?
Yeah.
And every side is given 8 centimeter, 8 centimeter. So triangle is half base into height. And sector 9, radius is given, theta is given. You can find area of sector. Clear?
A triangle is where?
This is a triangle OABD, right?
Mm,
ABD is a triangle.
yeah.
Yeah. So you are
Mm,
doing sector minus triangle. So you will get this red area, right?
yeah.
I mean, this area is sector minus triangle, right?
Yeah.
So
And multiply by
basically,
2.
yeah. So basically, this segment you are finding out, right? So once you find this segment, so in the end, you have to just multiply this area by 2. That's it. So you will get the complete, this area you will get this complete. Because half you are finding, another half is also same, because other quadrant is also having radius 8 centimeters. So no need to find it separately, just multiply by 2.
All right, ma'am.
Okay. So just try to complete both the questions.
Yeah.
Okay, then you can leave now.
Thank you, ma'am.